Welcome everyone, and thank you very much for the introduction. Today we from the TWAIN working group and PDF Association want to present to you a new ISO standard, ISO 2354, brand new 2020 PDFR for modern, reliable and secure image transfer. So PDFR stands actually, the R stands for raster data, and that is the document management applications series, raster, image, transport and storage. So my name is Rene Rebe, founder and CEO of Exacode GmbH here in Germany. We are also a board member of the TWAIN working group. TWAIN, many of you might have known or realized this is for scanning. So many of your scanning on Windows and Mac usually goes through TWAIN drivers. And I also, in the process of standardizing PDFR, became the ISO project leader for the standard. So you might wonder, why actually did we need a new PDF standard? Could we not just use any of the other standards? And that's certainly a fair question. So we started to create this around 2016 for a new scanning standard, TWAIN Direct, which is supposed to be a new and modern standard for driver agnostic network and cloud scanning, because the existing standards are, as you've seen, on your Windows drivers, so you can't just use a Windows driver on your iPad or Android phone. So that is, we envisioned a new way of interfacing with this hardware, and we needed some transfer mechanism for that. So historically, those kind of drivers, even today on your Windows machine, transfer the data raw, often in memory, very low level way, or alternatively Windows bitmaps and TIFF and JPEG. Windows bitmaps and TIFF because it's just in such an old standard. And we could, of course, just have used JPEG and TIFF, but both of them have some problems for our use case. JPEG, for example, doesn't support multiple pages or multiple images. As you might have noticed, you take a photo, you have one JPEG, and usually you probably want to scan more than one page. And also JPEG doesn't support black and white natively, like 1 bit per pixel for black and white. And we could also have chosen TIFF. However, there is limited browser support. So some web browsers support TIFF, like probably maybe Firefox or so, but not others, like maybe not Safari or the other way around. But there you see, even developers, like, yeah, some software does support it, but some not. And also TIFF is not a standard that is actively developed. We were also additionally, even if we would have somehow worked with this, we were additionally looking for encryption and digital signatures, because it's in this day and age, it's certainly very nice to not only have your files encrypted, but in professional workflows, e-government or other commercial business workflows, have documents directly signed, digitally signed on the machine where you create the file. So we could, of course, also just have used PDF. And although PDF is very versatile and, as you certainly know, very feature rich, for some use cases, such as ours, PDF simply had way too many features. For example, vector graphics and text, what you use on a daily basis for all your emails and Office documents and so on, even 3D and multimedia. But that is everything we didn't need in scanners and printers. And the problem is, if we don't limit what can be transferred, there would be a user, as you know, the users always try everything, and then some mobile phone in some workflow could receive those data and either couldn't process the data, or in the worst case, even crash or have security issues of trying to do something with the data and not being programmed in a way to handle this. So with PDF having so many features and thousands of pages in the standards that we didn't need, we started to draft a standard document for us internal use, or some request for comments on RFC, with just the features we needed for image data, like pixel data scanned or photography, and nothing more. That was in 2016, and the PDF Association started to join this and work together with us. And we created this standard for just PDF, for just raster pixel image data, scans, photos, and printing, for example. And so what is the problem with existing PDFs? For us, well, it's not a problem just for our use case. So for example, imagine we would just say, okay, use a standard PDF and just put an image into there. The problem is that all applications actually do that differently, because you can have a Word document with just one image or many images. And so even we found in the market today, all the printers that scanners that could already create PDFs did this in different ways. For example, as you see here in this illustration, there might be a good scanner might recognize that there's only like a passport photo or a birthday card and create one small image in the page. Another machine, for example, can scan slightly larger than ISO A4 and so create a PDF with the media size A4 but a larger image. There also might be machines that don't have enough memory and start creating PDFs with many small images on there. A very good professional scanner might even detect the skew and save the image slightly skewed, or even start in color and later realize there is only gray and save the rest in gray. These are, of course, all phenomenal features, but the problem is that if you want to process this data, the application has a very hard time to stitch this together in a reliable and efficient way. So what PDFR also defines is that the media size of the PDF, the canvas where it's being drawn on, only includes one precisely aligned image, or in case of lower memory devices, this kind of stripes to support this low memory use cases. And so yeah, our solution in the end, PDFR, PDF for raster data, just 25 pages describing the allowed standard subset of ISO PDF. This also means that it's 100% compatible with all existing PDF software. So there's nothing new. It is just precisely describing the subset to be used, and also not only the subset, but in which way precisely to allow this kind of workflows, scanning or printing in the cloud and mobile applications to interact reliably. So only images, no vector outlines, text, and so on, and well-defined image placement, so no stitching, well, only stripes, but so precisely, not like a little bit off, a little bit larger or smaller. So what you expect from a TIFF or JPEG, that the pixel data covers the whole page. In the end, it also became PDFA compatible, a goal not initially on our wish list, and also supports ICC profiles. So you could directly create PDFRs that are PDFA compliant with ICC profiles for long-term archiving. And as I mentioned, for this kind of cloud use cases, encryption and signature directly from the device, so that in business and e-government workflows, it is known who created this device. So PDFR features, what is left in the end for you and developers to use? Multiple pages, as I said, very important, more than one image or more than one page, ICC profiles for scanning with color calibration, and however, no affine transforms. So this means, as I showed earlier, no skewed image, no rotation, except 90 degrees, but not through these transforms, and no cropping. This means that applications have easy direct image access. There are no transformations to be applied. And this also means that you do not need a whole PDF framework, like a huge library, because due to the nature we defined PDFR very specifically, it does not require a full PDF library or render or rasterization pipeline to display these images, because the images in the file can be used directly. And this is also very important to access the original image data without any anti-aliasing or any other rasterization steps that would create imperfections, so that you have 100% direct access with any loss of information to the pixel image content. And if you need for lower memory use scenarios, multiple image strips, but again, very precisely defined for very long images like medical and other mechanical drawings. The benefits of PDFR benefits, what does this allow you? So this allows easy and efficient extraction of the original image data without the whole PDF rendering steps, guarantee simplicity and compatibility with consumer applications like sync multiple vendors from vendor A to vendor Z in the scanning and printing industry to be able to scan and print and process the data with, for example, mobile and cloud applications in between, and compatibility for the consumer to be sure that when he say purchase a new scanner or printer, that this works together without any compatibility issues. For us, very important was that it's small enough for scanner firmware, because as I said, creating full PDFs might be, or creating and processing might be rather complicated due to all the features, so that very small firmware, what usually is currently installed in scanners and firmwares, can deal with this. But also drivers think if a cloud and network scanner might require a operating system driver, Windows, Mac OS, Linux, and so on. So if you want to process this in drivers for network scanning, that is very ideal, and certainly mobile applications. We think it can be written, or we have examples where PDFR can be generated with just some 100 lines of code, and it actually might be easier to write PDF raster files than TIFF due to not requiring very low-level tagged byte field creation that TIFF is based on. And we think that for people often in the driver and industry think of PDF to be rather complicated, so that is often very surprising to hear for them to hear. And also for cloud application, you might think, okay, in the cloud we have very big servers and scale them dynamically nowadays, but this even improves security in the cloud applications due to a significant smaller trusted computing base that is a term in the computer industry for, like, basically this is like lines of code. So as I said, very, very lightweight to implement with very, very few features, with direct image processing. So in contrast to having a full PDF stack, it is significantly smaller, which might be ideal for many cloud image processing workflows. Think OCR services, other e-government form processing services might have for them it might be an option, and for the security benefits to in the future use PDFR or limit input processing to PDFR for them to have better security in their applications. One very specific trick I wanted to point out. So basically, I don't really need a slide for you to show how PDFR looks, because it's basically regular PDF. But one thing I wanted to point out is a very specific file header. Normally you would think it is in the beginning, and of course the regular PDF header is in the beginning, marking it as PDF. But we realized in the process of standardization, due to the nature of today's PDF workflows, people on a daily basis use their PDF applications on the desktop and modify files. And if we would have used, or if we would not have added another marker in some way, people could use a PDF, OCR it, and it might not immediately be visible for in consumer applications that it's not PDFR anymore. For that, we, after a lot of back and forth, settled on having a marker at the end of the file for the very specific reason. The beginning of the file might always stay the same for incremental updates, for digital signatures, for adding an OCR layer, so that a marker in the end actually most likely 99, hopefully 100% should be invalidated with incremental updates or rewriting the file by your favorite PDF consumer or processing application. That is the major thing that is to keep in mind, especially for developers dealing with this file format. So PDFR, I talked so much about scanning and printing for who is it and where. So we came to the conclusion, especially with so many people have shown interest during the standardization process, as it is now an ISO standard. We got so much positive feedback from people that it can basically be used everywhere as a modern replacement for TIFF and JPEG, because it basically can store everything that JPEG and TIFF can store with the same compression levels and compression methods. Actually, most TIFF and JPEG files should actually be one-to-one directly be convertible to PDF raster files with any loss or any recompression. From our initial target from scanning and printing, of course, MFPs, for example, printing, a lot of entry-level printers require some raw data to be sent. So even printer vendors are interested for using this for mobile applications, for mobile printing, multifunction devices, smartphones, theoretically even digital cameras, so that theoretically you could directly save to PDFs there. And all, as I said, all image processing workflows, especially in mobile and cloud application, due to the much lower requirements in code size and direct guarantees of direct pixel access and direct mapping and extracting of pixel data. And certainly e-government and all business-to-business solutions, invoice form processing, voting, and everything, basically everything in this area, and you can imagine for your solutions. So after going through PDF raster and presenting to you what benefits are there and what new developments and what new possibilities, I wanted to quickly also point out where this is coming from. Only very briefly, if you want to see more details, I gave a similar talk, I think about 3 years ago with the PDF Association, some PDF days, that you can watch there on their website, that has much more details, not only from TIFF and JPEG and PDF details, but also TWAIN Direct. Today, only a very short note. So this is just some illustration in the modern connected world with mobile devices, smartphones, tablets, laptops, and home and business, and having office data being accessed and transferred the whole day. And there is where this shines and where it was invented. And so TWAIN Direct is a new network scanning protocol. The previous TWAIN Classic, what you use today on Windows and Mac or Linux, is a C-based API that works in memory, very low level. I don't want to go too much more into detail today. Again, the previous talk has much more details, but the new protocol is entirely different. In contrast to like old-fashioned machine language, like C programming APIs, it is a network API. It is JSON-based, so JSON is a JavaScript object notation from the web, from web programming, and so that you don't need to deal with function calls, with low-level bits and bytes and structures. And the emphasis also on success. So with the old API, you had to negotiate what does the scanner support in a very low-level manner. And with the new TWAIN Direct protocol, first of all, you basically need to do nothing. You can connect over the network and initiate some JSON-based requests that I show you in a second. And so basically, you don't need to control everything. All the complicated negotiation phase goes away. You can still configure details if you want, but the emphasis is on success. And even if you configure something, if the scanner by default, if the scanner doesn't support it directly, it should still perform the action so that the user isn't confronted, especially in mobile and cloud use cases, with error messages like scanner didn't support 600 dpi or color scanning or duplex, but the application can still proceed to scan some data. And we think it greatly simplifies application and development of solutions based on this. So how does it work? Again, I keep here out all the connection mechanism because I don't think it's relevant for this talk, but just to show you some example how simple this is in the modern connected web and mobile world. this is how this JSON looks. Again, this is basically JavaScript object notation. And instead of, again, this low-level function calls and negotiations, you just create this object notation with your configuration. And basically, if you wouldn't even need this. So basically, you connect to a device and say scan, and you get this PDF raster directly instead of having to deal with low-level image processing. And if you want to configure something, it would look like this. And this is, for example, to configure, you want 24-bit color scanning with a resolution of 300 or 200 dpi. And only, as I said, emphasis is on success. Only if your application requires for some reason that the user gets specifically 300 dpi, or it needs to be scanned duplex, then you can supply additional attributes for exceptions, as shown here, exception fail if any of those values couldn't configured. Again, this is just a brief introduction, of course. The details are many more details to configure in terms of scanner functionality, but I think this illustrates or should illustrate where these APIs are heading to, how simple working with devices is in the future, and especially in this use case, directly delivering PDF, greatly simplifying application development, solution development, and users live on a daily basis of not having to do format conversion, receiving a JPEG or a TIFF, and directly getting what they later want to work on anyway. And with today's modern PDF features, digital encryption and digital signatures. So for even much more professional workflows than before, directly digital signed, of which user created this or which department, and with encryptions. So the benefits, as I said, receive PDFs directly from your scanner or multifunction device. And again, some vendors are looking into this for printing as well, so that in the future, many more entry-level scanners could directly support PDF instead of low-level and incompatible with driver installation. So it could also take in the future more and more driver installation away from printers, as we do on the scanner side. TWAIN Direct driverless, especially for mobile devices, because certainly you can't install a driver on your iPhone or Android tablet. And we support both local scanning, local use cases, and through the cloud. These are two standards. So it's TWAIN Direct local, and that is a base standard, and TWAIN Direct Cloud is an additional standard for cloud communication and APIs on top of that. What is the future, or what do we envision for the future for PDFR upcoming revisions? So right now, for the first years, we worked on getting the standard standardized, and through the ISO, worldwide ISO process, we left some details out, like object streams that some of you might know for better encryption or encrypting more details, as well as slightly better compression, among other things. So maybe in the future, so allowing object streams, the usual improved and new encryption. Certainly there will be every few years updates in PDF encryption and digital signature algorithms, and that is certainly something we need to look out for and keep track and support. We are also greatly interested in new compression algorithms that are not yet in the PDF 2.0 standard. Currently, there are talks, and we're working on for higher efficiency image formats that some smartphones already started to create in their phone applications. So this is a HEVC, a high efficiency codec, or AV1, for example. But yeah, this is still work in progress. And if these are areas that you're interested in, it would certainly be helpful to work through this with the PDF Association and join the working groups in this area. If you are not yet member of the PDF Association, also certainly these are this kind of things to join for, to work with experts in the industry and define and the new upcoming standards for that. And yeah, open to hear for your suggestions. There are websites for this, so more information online on pdfraster.org, as well as TWAIN Direct for this PDF and scanning standards. You can also reach me directly if you want with questions or, as I said, suggestions. So if there is something that you would need in future revisions or have expertise in high efficiency image file formats, codecs, that is certainly something in this day and age to join and work on together. So this are the slides so far. I hope I'm somewhat in time.
Yes, thank you, Rene.
If there were questions in the audience during the presentation.
There are, and I can provide them to you. So we're going to take a couple of questions. If you do have any other questions for Rene that you haven't already submitted, please do go ahead and put them into the chat pod. So Rene, the first question, will you provide sample PDF-R files for testing with existing PDF readers?
Yes, they are they should be on the website. I think I checked this weekend and saw them there. They should be on pdfraster.org. We also have open source sample code that you can, I think it's on GitHub, linked on the pdfraster site. So if you are interested in some low-level C code that is written in some ways to be usable even in scanner and printer firmware, that is also something, it's open source, so it should be directly usable should you choose to base your solution on that.
Okay. We have a question from Julian, who says, who asks, from the PDF point of view, it seems that PDF-R is just a PDF file with pages that simply have CM and do operators. Is that right?
Yes, that is correct. And as I said, I'll just create once another on maybe focus. As I outlined earlier, so what is part of the standard is that you need to write them very precisely. So the PDF-R standard defines very precisely what kind of operators can be used or must be used, because a low-level PDF-R processor will actually not look at the page content stream at all. It will directly use the images for efficiency reasons. So while it is a valid PDF and it will look exactly the same on a regular PDF application, care needs to be taken to follow the standard precisely so that PDF raster, PDF-R based consumers get the same view as evaluating the standard PDF page content stream.
Okay. Another question. What X-object stream filters are allowed? You were talking about JPEG converted to PDF-R, but is DCT decode filter allowed?
Yes, so JPEG, that is exactly right. So DCT decode is allowed. So that would be a JPEG. Basically, from my memory, nearly everything should be allowed except JPEG 2000 right now. So this means deflate, or what it's called, and basically should be with PNG based filter or predictor, I think. So basically mirroring exactly the available TIFF compressions as well as JPEG. So as I said, the only thing, maybe there might be some exceptions. I'm not sure if maybe this ASCII filters are allowed, but you would need to look up the standard for that. But that is certainly not the point for compression using the ASCII filters. So all the reasonable filters are allowed except JPEG 2000 and JBIG. We both kept this complex compressors out of there because we didn't want to burden consumers in the mobile cloud and firmware driver space to be able to deal with those. This would be the only two major ones that are currently not allowed. And as I said, even JPEG 2000 is already a little bit dated, 20 years now, exactly 2000 to 2020, 20-year-old. So we would rather, instead of adding, some people ask for JPEG 2000, we would be rather looking forward to higher efficiency image file formats, because after 20 years of innovation and research, is where we, in this day and age, would see the highest benefit for even the regular PDF 2.0 standards in the future, instead of adding every legacy codec that exists like JPEG 2000 to PDF raster in the future. But again, open to your suggestions. If too many libraries and archives say they need JPEG 2000, maybe that is also an option. But right now, at this current state, many members are rather asking for higher efficiency image file formats for the future.
Okay, and probably our last question here is, have any scanner companies committed to adoption?
Yes, so the TWAIN working group represents all the major scanner vendors, and they are all working, as far as I know, all or nearly all are working for supporting TWAIN Direct and as a future of driverless and network agnostic scanning. So, and TWAIN Direct is using PDFR as the main transfer mechanism. So a TWAIN Direct compatible scanner must support PDFR. It could support optionally additional things. For example, you could, if you have a very fancy scanner or copy machine that scans to the network and the cloud, you could theoretically negotiate if your mobile application or cloud application supports full PDF to receive full PDF, for example, even with an OCR layer. But these are optional features and vendor-specific features. The base TWAIN Direct standard calls for support for PDFR, so all TWAIN Direct and TWAIN Cloud scanners in the future will support PDFR directly from the firmware.